Hi everyone, I'm Emily. Today we're going to be introducing how QSAN can help you with the process of simplifying storage management. We're going to be taking a look at how containerization and CSI can help, and how QSAN along with MSPs can help you take the first steps in digitally transforming your business into cloud nativity. Cloud natives are businesses who are capable of making cloud technology the centerpiece of their business operations and culture. So much so that their business goals, strategies, practices, platforms, audience groups, product categories, resourcing, supply chains, employee recruitment, and everything in between are subject to change along with it. Because cloud technology presents unlimited growth opportunities, businesses find themselves expanding and capturing new markets to gradually secure long-term sustainability. Virtual machines is the mainstream technology for virtualization, as what we're used to, when containers are growing and treated as next-generation mainstream technology. Both containers and VMs have benefits and drawbacks, and both have their specific use cases. First, start from the comparison of architecture. VMs are heavyweight, offer limited performance, and host applications that run on their respective OS. They have hardware-level virtualization in comparison to containers. On the other hand, because it's fully isolated, it might be more secure. Whereas cloud-enabled solutions are created for deployment in traditional data centers, cloud-native applications are made to reside in cloud ecosystems, with the pros being quick implementation, lower hosting expenses, and licensing fees. Cloud infra includes hardware, storage, virtualization software, services, servers, networking, DevOps, and other microservices. Going cloud-native is a mindset and a continuous process. It's high time to embrace the cloud-native mindset and approach for digital transformation. This can be done by designing and building your applications in a new way. Despite VMware being the dominant software of today, it can't escape the age-old problem of bottlenecks. Cloud-native requirements are fulfilled by VMware, but storage space and CPU memory can be further lightened. From this survey conducted by Cloud Native Computing Foundation, the adoption of container technology has increased a lot and keeps growing cross-region-wise. Containerization refers to the creation of standardized software packages. Often, a container will include an application and all of the software components needed to run it, no matter where they live, on a laptop, in the cloud, or on an on-premises data center. There are several major reasons why containerization is becoming largely popularized. The first is standardization. For example, by placing all of the goods into standard containers, loading and unloading vessels becomes much more efficient. The second is portability or mobility. For convenience of movement, standardization also enables mobility of containers amongst different means of transportation. From the software point of view, in the traditional way, if you want to install an application on your laptop, you need to choose the right version of software to install, such as for Windows, Linux, or Mac. Even in Windows, you need to choose from editions such as 7, 10, or 11. These are typical examples of non-standardization, and each platform needs a proprietary app to be run on it. This is the illustration of containerized environment in IT. Containers can be easily turned on, off, and moved among different environments, such as between DevOps and production, on-premises, and cloud. Former Docker CEO's quote establishes that the intent of containers is to resolve the issue of application mobility. The technology allows developers to divide software into many small pieces called microservices that serve a single purpose, and those services can be developed and deployed independently of each other instead of in one monolithic unit. From Gmail to YouTube to search, everything at Google runs in containers. Here are two more examples, and the first is eShop. Let's say you have an app that allows customers to buy anything in the world. You might have a search bar, a shopping cart, and a buy button. And each of those services can exist in their own container, so that if the search bar fails due to high load, it doesn't bring the whole shop down. Or more containers of microservices can be turned on quickly to handle peak loads during promotion and turned off after promotion period. The other example is the Pokemon Go mobile game. After its launch in 2016, suddenly it was everywhere, with over 10 million downloads in its first week and 500 million downloads in 6 months. Its system load rapidly escalated to 50 times the anticipated demand. How can the game architecture support such an out-of-control hypergrowth? At release time, Pokemon Go was the largest Kubernetes deployment on Google Container Engine. Docker and Kubernetes are common, but sometimes people get confused on what their differences are. Let's check the definition. Docker is an open source platform that enables developers to build, deploy, run, update, and manage containers. You need a container runtime like Docker Engine to start and stop containers on a host. Kubernetes is not a container software, but rather a container orchestrator. It coordinates lots of microservices that together form a useful application. Kubernetes automatically and perpetually monitors the cluster and makes adjustments to its components. Once we have some basic understanding of commonly used terminology, let's take a look at the architecture of Kubernetes. As mentioned, Kubernetes always involves a bunch of containers and clusters, including several components such as a master node, working node, and a pod. Other concepts include auto-scaling, self-healing, and storage orchestration. Container Storage Interface, or CSI, is a standard that defines a common set of interfaces. CSI enables storage vendors to write plugins that work across container orchestration systems, such as Kubernetes. Although prior to CSI, Kubernetes provided a powerful volume plugin system, it was challenging to add support for new volume plugins to Kubernetes as it was part of the core code. Addition of new storage system support was forced to align with Kubernetes release processes. Using CSI, third-party storage providers can write and deploy plugins, exposing new storage systems in Kubernetes without ever having to touch the core code. This gives Kubernetes users more options for storage and makes the system more secure and reliable. And that's why QSAN has developed CSI driver to simplify storage management. Using QSAN, CSI storage providers can write and deploy plugins to expose new storage systems and container orchestration systems, like Kubernetes, without touching the core code. QSAN CSI driver supports iSCSI and Fiber channel protocols for most volume management functions. An enterprise container platform is a platform for developing and running containerized microservices applications. This means it's so much more than just Kubernetes, the container orchestrator. It includes many, often open source solutions to manage container-based applications in production. It includes services for the development of these applications too. For many businesses, the lack of IT know-how and support to deploy and maintain a Kubernetes architecture is a large barrier to adoption. Managed Kubernetes supply can be an opportunity for MSP partners to grow business. MSPs are crucial because they can help SMBs host cloud environments so they too can wield the benefits of containerization. QSAN can help with our storage and CSI driver. Thank you for watching today's video. We hope that our introduction about containers and QSAN CSI was informative. Please feel free to contact QSAN for more information. If you enjoyed today's video, like and subscribe to QSAN's channel.